The Geant4 installation guide lists a bunch of programs to be installed before the compilation of Geant4. They're called prerequisites. I've talked about those programs on Mac OS and Windows in my channel. However, in my tutorial of Geant4 compilation in Linux about 2 years ago, I just assumed that those prerequisites were already installed. This is certainly not the case for many beginners. That's why I'm going to use the most popular Linux distribution, Ubuntu, to demonstrate the process of identifying and installing those prerequisites to compile Geant4. The demonstration will be done using the Windows subsystem for Linux, but the process will be the same for a physical Linux computer. Let's search Ubuntu in the Microsoft Store and get the latest long-term support version of Ubuntu. Click Ubuntu in the Start menu to launch a terminal. Create a new user for our fake Linux machine. I like to keep my system up to date. The first thing I do is to run apt update. Apt is a software managing program for Ubuntu. Sudo is used to run the command after it as the system administrator. If you cannot gain the administrator's privilege, your only choice is to install everything in your home directory manually, instead of using a software managing program. This is typical if you log into a remote Linux server. I may cover that in the future, but for now, I assume you own your Linux. Apt update only updates the software database on your Ubuntu. Apt dist upgrade is the real command to install all the upgrades. This may take some time depending on how much your system is out of date. Now, let's download the latest Geant4 source code. Right-click on the button, download tar.bz2. Select Copy Target URL from the menu. Type wget and space in your terminal, and then paste the copied URL behind it. In case you wonder how to copy and paste in such a terminal, click on the icon at the corner of the window, select Edit in the drop-down menu, and then select Paste. Notice that Ctrl-V doesn't work for me in this terminal. wget is a command to download a file from a link. It shows the progress of downloading process in the terminal. After downloading, type ls to check if you really have the tar.bz2 file in your folder. Use tar command to unzip this file. Option X means extract. J means the file is a bzip2 file. F means file name, which is the file we just downloaded. The tar command complains that the bzip2 command cannot be found. Let's just use apt install bzip2 to install this program. After that, run tar again. This time, we got a folder extracted from the bz2 file. cd into that folder, run ls to check its contents. There is a cmake-lists.txt file. It contains instructions for cmake to configure the compilation process. Let's use mkdir command to create a new folder called build. cd into it, type ccmake space ... to start the configuration. ... means the parent folder which contains the cmake-list.txt file. The system tells me that ccmake cannot be found, but it is smart enough to suggest a command to install it. So let's just follow this instruction to install cmake-curses-gui. After the installation, we can run ccmake to get into cmake's terminal user interface. Type C to start the configuration. cmake complains that no C++ compiler can be found. Press E to return to the main screen, and then press Q to quit cmake. Now we're back to our terminal. Use apt install g++ to install the C++ compiler. How do I know that the C++ compiler package is called G++? This is just experience. After installation, let's type ccmake space ... again. To get back to cmake, type C to configure. This time, the compiler is found, but the package called expat is missing. Let's quit from cmake and use apt install expat to install it. After that, get back to cmake. Run configuration. The error is still there. To find out why, we'll have to read the error message in detail. Missing the library and the include directory. I guess Geant4 needs expat's header files to compile. We just install the library, but the header files are still missing. Normally, header files are included in packages ended with -dev. I try to install expat-dev, but that package doesn't exist in the system's database. I tried expat-devel, which also does not exist. Now I must ask Google. It turns out that the package is called libxmu-dev. I would never be able to guess it by myself. Anyway, it's done now. Let's go back to cmake. Now the configuration can be done successfully. Press E to go back to the main screen, where we can turn on and off some features by pressing Enter. I always turn on install data so that Geant4 datasets will be installed automatically for me. OpenGL, Qt, and Raytracer are all very good visualization tools. I normally enable them all in Linux and Mac. I don't use Qt in Windows because Windows native Geant4 GUI is good enough. I have another video dedicated to that topic. Come back to our current business. The install prefix specifies where the compiled Geant4 libraries will be installed. If you don't like the default location, feel free to change it. After all this customization, press C to configure again. This time, cmake complains that Qt5 is missing. Let's go back to the terminal and install Qt 5-dev. How do I know the package name? I googled it. After installation, go back to cmake to configure again. This time, cmake complains about 3 missing Qt packages: Qt 3D Core, 3D Extras, and 3D Render, as well as an X11 XMU library and headers. Go back to the terminal. Use apt search Qt 3D to find the right packages to install. The list is very long. If we go through it patiently, we can find Qt 3D 5-dev, which sounds like what we are looking for. Let's try to install Qt 3D 5 Dev, 3D Core, 3D Extras, and 3D Render will all be installed automatically. That's great. One stone, three birds. apt search xmu, libxmu-dev should be what we need. You may ask, why not also install libxmu headers? This is because libxmu-dev include both library and the headers. Let's install it and go back to cmake to run configure again. This time, everything is found. Press C again until we get the generate option. Press G to generate makefiles. ccmake will quit automatically back to the terminal if the generation of makefiles is successful. Type ls to check files generated by cmake. Indeed, we can find a makefile there. Run make to execute instructions in the makefile. Geant4 datasets will be downloaded automatically before the compilation of Geant4. While we are waiting for the lengthy compilation of Geant4, let's look back at what we've installed so far. bzip2 is used to extract the Geant4 source files out of the downloaded tarball. cmake-curses-gui provides the ccmake command. G++ is the C++ compiler. expat is required by Geant4 in Linux. Qt 3D is optional. We actually installed Qt base first, but if we install Qt 3D first, Qt base will be installed automatically. This is because Qt 3D depends on Qt base. xmu is a collection of miscellaneous utility functions for X11. If we know all of this in advance, we could have used this single line of command to install all prerequisites and run ccmake only once to finish the compilation. In other Linux distributions, the software management program may be different, and the package names may vary as well. But common sense and Google search should always be able to help. Now let's go back to our terminal. The compilation is done. Run make install to install the compiled libraries. It failed after a while, giving the error message. File install cannot make directory user local something something. Of course, this is because user local directory is not my personal directory. Linux pays a lot of attention to security. It does not allow me to write into this system directory. I need to prefix the make install command with sudo to turn on the administrator's privilege. This time, the installation went through. Datasets are installed in the user local share Geant4 directory. Examples are installed in the same directory. How about other files? First of all, I want to draw your attention to 3 scripts started with Geant4 in the user local bin directory. Geant4-config, geant4.csh, and geant4.sh. Geant4-config provides a lot of options to print out information of this particular Geant4 installation, such as which features are turned on, which are not. Qt, Ray Tracer, and OpenGL are all enabled, as we expected. Geant4 config version will print out the installed Geant4 version. Prefix will print out where Geant4 is installed. Libs will print out all the Geant4 libraries and their location. cflags can tell you where you can find Geant4's header files. Datasets will print out version number and location of all the Geant4 datasets. Geant4.sh and .csh are needed in the so-called post-install setup. They are used to set some environment variables for the system to find Geant4 libraries and datasets. C shell is an old shell. We can safely ignore this file. We can use source geant4.sh to use this file. To check the effect of this command, let's print out the contents of the path and LD library path before this command and after this command. Before this command, LD library path is empty. After it, LD library path includes the location where Geant4 libraries are installed. User local bin directory is also added to the path environmental variable. Another environment variable added by this command is called Geant4 data dir, which points to the location of all Geant4 datasets. In order to source this file automatically, whenever we open a terminal, we need to add this line at the end of the .-rc file in your home directory. All files start with a dot are hidden files. We need to use the -a option with ls to show them. Now we can download a simple Geant4 example application, Gears, to verify our installation. Click Code. In the drop-down menu, copy the HTTPS address of the code. Type git clone in our terminal. Paste the address behind this command. After downloading, you should have a new folder called Gears in your current directory. cd into it, list its contents. There is already a Makefile there. So let's just type make to compile gears.cc file into an executable Gears. Optionally, we can move this executable to a system path, such as user local bin, so that we can run it everywhere. Now let's try it out. Oops, it doesn't work out. The error message is related to libqt5 core. Some Google search tells me that this is related to WSL. So if you use a physical Ubuntu machine, it could have just worked out. Anyway, if you also use WSL, you will have to stay with me a bit longer. The problem is that I used WSL version 1 instead of version 2. To confirm that, let's type exit to quit the Ubuntu terminal first. Open a native Windows terminal and type WSL list verbals. Indeed, my Ubuntu is running on WSL version 1. It turns out that changing to version 2 is easy. It takes only one line of command. Let's give it a try and check the version number after the execution of this command. Indeed, the problem is fixed. Let's click Ubuntu in the Start menu to bring back our Ubuntu terminal and run Gears there. This time, Gears could run, but Qt UI doesn't show up. According to Microsoft's official documentation, the latest WSL should be able to handle Linux GUI automatically. but I may have to update my WSL to include this support. Let's just follow this instruction to update our WSL and then shut it down to be prepared for a restart. After we launch the Ubuntu terminal, Gears could run without any problem. And the beautiful, cute GUI finally showed up. With so many problems, I would not recommend a Geant4 beginner to use WSL. You should use a physical Linux machine instead. Or if you stay in Windows, you should use the native Windows toolchain to compile and run Geant4. If for some reason you will have to use WSL, remember to update it and also to make sure that your Ubuntu is running in version 2 of WSL. Thank you for staying with me for such a long video. Hopefully, I showed you how to deal with unexpected situations in the installation process. After all, my job is to teach you how to fish, not just to give you one. Happy fishing!